Sweet. Okay. So today, talking about adding and subtracting, sums, adding, differences, subtracting. Oh, don't tell me this isn't going to work either. Oh no.
You should calibrate it.
I don't think that's going to help.
You.
There we go. Okay. In order to add or subtract radicals, we need two things. First off, always like before, our index needs to be the same. Remind me what index is. The small number outside our radical. So that needs to be the same. And only adding and subtracting, our radicand needs to also be the same. When we multiply and divide, it doesn't. When we add and subtract, it does. Radicand, remember what radicand is? Under our radical, yeah, under the square root thing. So here you'll notice same, index same. I feel like we did a little bit of this before, but I could be wrong. All right. So in A, I have 8 square roots of 2 plus the square root of 2. Is my index the same?
Nope.
Yep. Is my radicand the same, the thing under it? Yep. So we're going to add. Obviously it tells us. Question, what's imaginary out here?
1.
A 1. So if I have 8 squared roots 2 plus 1 squared root 2, how much squared roots 2? Awesome. 9 squared roots 2. Okay. In B, do I have the same radicand, the same thing under?
Right.
I have the same thing under, right? Do I have the same index?
No.
No. Can I subtract if I don't have the same index? No.
Yes. No.
If the index is not the same, cannot do it. No solution. Not possible.
Or wouldn't 7 square root 3 over 5 and then 4 square root 5 be the simplest? Like that is the simplified.
Right, yeah, like you can't simplify it anymore. Yeah. I get what you're saying. So simplified form, you could say we write the same thing. Yeah, I get what you're saying. Okay, other questions so far? Alright, C. Is my radicand the same? Uh-huh. Is my index the same?
Yep.
Yep. So, outside first, what is 3x plus 4x?
7x.
7x. And then what do I put?
Square root x.
Square root xy. Good. Okay. D. Radicand the same? Mm-hmm. Is my index the same? Mm-hmm. So I gotta take 7 minus 5 and I get 2. 2, then what? Go John.
4.
Yep. 4 root of what? 3. Awesome. So pretty much whatever is the same stays the same at the end. Okay. Questions so far? Not yet. Okay. We got a little word problem thing. It says, oh, too much. Stained glass window. The side of each small square is 6 inches. Okay. I need to find the perimeter of the window to the nearest tenth of an inch. Okay. Perimeter. Remember what perimeter is? All the way around. So I need to find this whole length and this whole length, right? Okay. If each side of my square is 6, so like this side here is 6, and this side here is 6, my question right up there. I need to find how much cutting it through it is, right?
6.
6? I don't think so. What are the angles of a square? Like, what's this whole angle? The whole thing is 90, so half of it would be 45, right? So if I got 45 here, let's blow this up. So I got 45 here. My corner we said is 90. My sides are each 6, so what does this length have to be? 6 square root 2. Very good. Okay. Well, the height of my window, how many of those do I have? Here's 1. I have 2. So how much is from here to here if they're each 6 square roots 2? 12 square roots 2. Add them. 6 square roots 2 from here to here plus 6 square roots 2 from here to here gives me 12 square roots of 2. Okay. What if I cut it this way? Is that still the same 6 square roots 2? Yeah. How many do I have going left to right? Here's 1, 2, half and half makes 3. So what is the length of my window? 18 square roots 2. Very good. So how's the electron perimeter? Not length of this area. Add them. She says, how many sides are 12 square roots 2 length? 24 sides?
There's 2 sides.
There's 2 sides that are 12 square roots 2 in length. So Gabe, that gives me how much? 24 square roots 2. How many sides are 18 square roots 2 in length? 2. So that gives me how much? 36. And what do I do with these two numbers? Do what? Add them. And I get how much square root of 2? 60. What's our label? Inches. Questions? Do we remember our 45, 45, 90 triangles? Mm-hmm. Okay. Alright. And subtracting, we said our index had to be the same, and our radicand had to be the same. In A, are 250, 54, and 16 the same? No. Are my indexes the same? Yeah. So if my indexes are the same, what I'm going to do is change my inside, my radicand, to simplify them to make them the same. Okay? So if my index is 3, we're going to need cubed roots to try and pull out to see if we can get our radicand, our inside number, to be the same. Okay? Who has a list of 3s? How much is 2 cubed? 8. How about 3 cubed?
6.
How about 27? How about 4 cubed? 64. And 5 cubed?
125.
125. Okay, so we're going to try to find numbers that go along with these, and hopefully they're multiplied by the same number so that we can simplify this expression, okay? Remind me why I wanted the cubes? Yeah, because my index is 3. Okay, 250. What can 250 be broken down by? 125 and what?
Twice.
Twice. So I'm going to turn my cubed root of 250 into 125 times 2. Okay. We good there? Okay, now I have plus cubed root. What can I break 54 down into?
27,
And
2.
27 and 2. That's not a 0.2, that's a times 2. What do you think I should be looking for in 16?
8.
8 and what? 2. What do you notice about all my radicans?
They're times 2.
They're times 2. So we need to pull out the stuff that's not 2, and then we can simplify, okay? So cubed root of 125 is
5.
5, so what can I pull out?
5.
5. So I'm going to have 5 cubed root of 2. Good there? Okay. Plus how much cubed root of 2? 3 cubed root of 2 minus
2.
2 cubed root of 2. Okay. Questions with that step? Yeah, then I just simplify. My outsides, my insides are all the same. My index is all the same. So now I just take care of my outside. 5 plus 3 is 8. 8 minus 2 is. So this all boils down to 6 cubed roots of 2. Where's my eraser? Okay, good, honey. Okay, we're gonna try the same thing with B, except for what's different about B compared to A.
There's only 2.
There are only 2. What else is different?
Yes. Cubed.
Yeah, I got a 4th, not a 3rd. Okay. So I want to break 32 not down into something from my cube list, but as a 4th root of something. Okay. What can I break 32 down into on a 4th?
2.
2, 4th root of 2. That's not helpful.
3.
4th root of 3. That's not helpful.
Isn't it like 116?
Yeah. 16 works. 16 times what?
2.
That's 2.
I said
Oh, I thought you meant like 2 times. How about 162? What should I try it by? What's going to be left is probably this 2, right? So try to break it down to 2. And what is 162 divided by 2? 81. Is that a 4th root list? It
Yeah.
sure is. Okay, now what are you? What are you gonna break it down? What do I gotta do? Yeah. Pull my 16 out, and 16 becomes how much?
2.
2. So I got 2 4th root of 2 plus
3.
3 4th root of 2. Now what?
5
Add
4th
them.
root of 2.
5 4th root of 2. I add them. Sweet. Okay. Questions? None? Okay. Alright. Multiplying binomials when we have radicals. Does A look familiar with our bubbles? Yeah. Do you guys remember how to multiply these? Nice little acronym.
Foil. Factor.
Oil, sweet. Only thing we did check is that our index is the same. Is it? Is our radicand the same? Yep, we're good to go. Okay. First, 3 times 2. 6. Plus outside 3 times 4 square root of 5. 12 root 5. Very good. plus my insides. 4 square root of 5. Okay, here's the tricky one. My lasts, let's do the outside number first. What is 4 times 2? 8. What is the square root of 5 times the square root of 5?
25.
Square root of 25, which is
5.
5. So I need to take 8 times 5. Okay. Are we good with that step? Okay. Now simplifying. How about 8 times 5? Plus 6. 46. Plus 12 square roots of 5 plus 4 square roots of 5. 16 square root of 5. Good. Can I combine these two numbers? No, I am all done.
I like this a little bit better.
This way,
A
right?
lot better.
I think it's like a lot worse.
No, a lot better than last week.
Oh.
Trey, I'm glad we moved on from that.
Okay, questions on A? Okay, B. What I like to do is I like to, instead of the squared, I like to rewrite all this. Okay? So we're going to go 2 square roots of 3 plus 3 square roots of 5. I think it just makes it easier for multiplying because, I don't know, I look at that too and I think, oh, what? Okay. First, 2 square root of 3 times 2 square root of 3. Let's do outsides first. What's 2 times 2? 4 times how much? No.
Root 3.
3. Square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is 3. Okay, are we good on that step? Yes? Okay. Plus my outsides. What is 2 times 3? 6. And now I have the square root of 3 times the square root of 5. What do we get there? Good. Square root of 15. Okay. When they're not the same number, you can't get rid of the square root. Okay. Insides. What do I get again? Good. And my last 3 times 3 is? Oh, close, John. 9. Square root of 5 times square root of 5? 5. Good. Okay. Let's do number parts first. 9 times 5? 45. How about 4 times 3? 12. What do I do with those two numbers? Add them. What do I get? 57 plus what? 12 square root of 15. Can I simplify the square root of 15? Nope. Can I simplify 57 plus 12 square root of 15? Simplify this whole thing?
No.
Nope. Done. Okay.
Actually, no.
Yeah, you said that out loud. Questions here? Okay, we're almost done. Alright, conjugates. You guys remember what conjugates are? Talked about when we had our imaginary numbers. All a conjugate is, one version has a minus, the other one has a plus. So if you're asked to find a conjugate and you're given this one, you would just write the plus version. If you're given the plus version, you write the minus version as a conjugate. Okay? Yes, no, maybe so? Dead. Molly put it away. Okay, same thing. What are we going to do to solve this? Yeah, distribute, yeah. FOIL. Okay. 6 times 6. 36. 6 times the square root of 12. Yep, plus 6 square root of 12. Good. How about 6 times minus square root of 12? Negative. Good. Negative 6 square root of 12.
Cancels them.
And then I have negative square root of 12 plus square root of 12.
Nothing.
Not nothing. How about, first off, negative times a positive is a negative. Now what's square root of 12 times square root of 12? How much?
24.
144. So square root of 12 times square root of 12 is 144.
12.
It's 12. It's a square root of 144, which is 12. Okay. I always think about it as just get rid of the square root. Okay, Jonah, you said what happens in the middle?
Cancels them out.
6 square root of 12 minus 6 square root of 12 is not a. All I have left is 36 minus 12, which is 24. That is the cool thing about conjugates, is that you get down to a whole number. Questions? Nope. Okay, last one. Who remembers what we meant by rationalizing the denominator? Making the denominator what? A whole number? Yeah, we don't want to have square roots, okay? Rationalizing means getting rid of square roots, okay? So here, I want to rationalize the denominator. What's the easiest way to get rid of square roots on the bottom? Times them by what? What did we just do up there?
By FOIL.
Times them by FOIL. How do I know what to times it by? Itself. So square root of 3 minus square root of 5.
Did you just do that?
What do you mean square root of 3 plus?
Ooh, yeah, my conjugate. My opposite one. Since I have a minus, I'm going to multiply by a plus. So I'm just going to write this whole thing because other words are in my way. So I got 2 square root of 7 over the square root of 3 minus the square root of 5. Allison says rationalize it by multiplying by the conjugate of my bottom. Okay? What would the conjugate be? Square root of 3 plus the square root of 5. If I multiply that on bottom, we'll have to multiply by on top. Same thing, square root of 3 plus square root of 5. Okay. Everybody with me so far? Okay, let's take care of our top. I'm going to write parentheses around this just because I think it's easier. If I have 2 square roots of 7 times the square root of 3, what happens with my inside? What did we do up here? How did I get square root of 15? 5 by 3, so what happens here? Square root of 21. I have my 2 outside, so I'm going to have 2 square root of 21 plus how much? Gotta distribute, right? I gotta take this whole thing times this and times this. Good. 2 square root of 35. Okay, I'm done with my top. On the bottom is where the fun stuff happens. Square root of 3 times square root of 3. 3. Tell me, what's going to happen if I take the square root of 3 times square root of 5 and then minus square root of 3 times square root of 5? They're going to cancel, so are we okay if I don't write that, or should I write that?
Don't write it.
Are we sure?
Or just write it.
Or just write it?
That's
Okay.
too long.
Plus square root of 15 minus square root of 15. Minus, what do I get back? Negative square root of 5 plus square root of 5.
5.
Positive 5?
Negative 5.
Negative 5. Okay. Question. What does the top stuff have in common? 2. So can I pull a 2 out? Make it look like it kind of looked before. If I pull a 2 out, I'm left with square root of 21 plus square root of 35. Other thing you should ask yourself, can I do anything with square root of 21, square root of 35? Pull anything out? Can I? 21's friends with 3 and 7. None of those are perfect squares. Right? Square root of 35 have any friends that we can pull out? No, I don't think so. Okay, so we're good there. My denominator. What's gonna happen here? Cancels. So I'm left with 3 minus 5, which is negative 2. Ooh, cool. What do you notice about this?
Cancel.
Cancel. So I still have a negative. I'm not going to leave my negative on bottom. I'm going to bring it up top. So I have negative square root of 21. Right? Because these cancel. So I have a negative that's going here and here. Minus square root of 35. Why does it go both places? Because it is outside. So distribute the negative. Okay. Questions? Rationalizing a denominator means what? Get rid of the square roots. When you have 2 of them, best thing